The sun is incredible. Even though it's a huge ball of mass, did you know it's an actual star? It's also the largest object in our solar system. It's crazy powerful, burning hot, and helpful to our planet in so many ways. It provides heat energy and light energy, both of which Earth needs to survive, stay warm, and produce food. Just be careful not to look directly at it though. It will definitely hurt your eyes. That's why so many people wear sunglasses. Have you noticed how the sun appears to change its place up in the sky during the day? Well, that's just because of Earth's rotation while moving around our sun. As Earth spins around and around on itself, the sun appears to move in a curved line in the sky. It appears to rise up in the east and set in the west. This also means that the shadows, which are created from the sun, change shape and size as the sun's position changes throughout the day. This pattern of changing place in the sky repeats every 24 hours. Here I have some cool dinosaur friends with me right now, and I am shining a flashlight right above them because this is representing the sun. Now we know that the sun rises from the east, comes all the way up above our heads, and then it sets in the west. And you're able to take a look at these shadows and look at how they change. Look at the shape of them. Look how they're following them. Make some observations. Ask some questions, such as, why does this shape seem longer at certain points versus shorter right now, and then longer again?
Here's a quick experiment about the sun and how it changes its appearance in the sky. As I shine the flashlight into just the liquid water, we're not able to see the light because that light energy doesn't have anything to bounce off of. But look at the difference when I pour a little bit of milk into a tub of water and turn off the lights. All of the proteins and fats and impurities found in the milk represent all of the dust and smoke and ash and other debris found in our atmosphere. So now our sunlight actually has something to bounce off of. When the light is shining on the side of the tub, that is similar to 12 p.m. or noon when the sun is up above us. And when the flashlight is behind the tub of water and milk, then that shows the bright yellows and reds during a sunrise or sunset.
I want to show you how this works. Basically, I just built a ruler with a flashlight like this, and you just attach the ruler to this kind of a semicircle base so that you can keep that light source in place as you're viewing the shadows on the white paper. So again, this would be 6 a.m. I'm lining up my line with those lines. 7 a.m., 8 a.m., 9 a.m., 10 a.m., 11 a.m., 12 a.m., 12 p.m., which is noon, 1 p.m., 2 p.m., 3 p.m., 4 p.m., about 5 p.m., and 6 p.m. And you can see how that shadow from my little person over here is moving all across my paper. And you can do this same sort of measuring outside during the day. All you have to do is start at a time Have one person stand still. You trace their outline in chalk, and you label what time it is. So you could say, I'm going to make a marking at 6 a.m. and then you trace their outline on paper, and you would say 6 a.m. and then you wait an hour, you go find something to do, you come back 1 hour later, and their shadow seems to have moved. You trace it on the sidewalk, make sure they're standing in the same place, and then you label it 7 a.m. and you do the same thing with 8 a.m. and then 9 a.m. and 10 and 11 and noon, and so on and so forth until you run out of daylight. But this is just a fun experiment that the kids got to do last year, and it's definitely something that you can do at home. All you need is chalk and then one person to stand still as you trace their shadow about every hour or so.